Hello everyone and welcome back to Diksha Karnataka YouTube channel, and you are currently watching KCET 60 out of 60 in physics series, where we are discussing each chapter topic wise, concept wise. Also we are discussing previous year questions. So if you have not yet subscribed to our channel, please subscribe to our channel. Also, every week we are conducting a special test series. We are calling it KPL or KCET Premier League for 2025 aspirants. So, if you have not yet joined our WhatsApp group, please join our WhatsApp group. The link is given in the description below. So, please join our WhatsApp group. Every update related to KCET 2025 and all the question papers will be provided in that channel, including all the subjects. Now, I wish you a very happy Ganesh Chaturthi today, and on the occasion of Ganesh Chaturthi, I am not going to give you a very full lecture today. I will just going through a chapter revision of electrostatic potential and capacitance. It will be very brief lecture. It will not be on a 1 hour long video. So if you are thinking, okay, today is Ganesh Chaturthi, we have done a lot of hard work throughout the day, then take relax, just see this video. It will very helpful for tomorrow's KPL. Yes, tomorrow there is a test. Okay, tomorrow Sunday at 10 a.m. around 10 to 10:30 you will be receiving your KCET Premier League Physics second question paper mock test number 2, and in the evening I will be coming back with the answers to those questions. So take a little bit relax. This chapter electrostatic potential and capacitance, some part is already covered in our mock test number 1. Some part we will be covering in mock test number 2, including the 2 lectures that we have done for current electricity. So current electricity, till that part that we have completed till yesterday, that and the capacitance that we have completed this week. So that including these 2 things will be covered in our upcoming KPL, that is tomorrow. You will receive a full question paper of 30 questions and try to answer them before evening, and in the evening I will be back with the solution. Right now, let's start with the chapter revision for electrostatic potential and capacitance. It is a very important chapter, and my intuition is that from this chapter number of questions this year will be at least 3 to 4. So based on that, I am going to do some revision. There will be no questions discussed in today's lecture. It will be only basic theory revision. So let's start with the revision. First is electrostatic potential and potential energy. Very important concept, that how they are interrelated. Okay, from potential, if they have given you potential and if they ask you to they have given you potential energy and they asked you to calculate the potential, then potential, this is potential divided by the charge. Okay, electrostatic potential energy, this is energy. Okay, and this is the charge. So potential energy per unit charge is the definition of electric potential. So in some cases, some problems, they will give you potential energy, or you have to calculate potential energy in some way, and then eventually you have to calculate the potential. So potential is basically electrostatic potential energy divided by the charge. Similarly, in some cases, in many of the cases actually, this is more common formula. This formula is very important, and here you have to calculate potential energy from a potential given. Okay, so potential given is delta V, and the charge is given. A charge is moving in an electrostatic potential, or charge is kept in an electrostatic potential. In whatever case, electrostatic potential energy stored in that charge is given by Q times delta V. Okay. Now, electric potential energy can be converted into kinetic energy. Now, this energy can be converted into kinetic energy. For example, when you take a charge, say Q, you keep it in a potential, say potential field at point A, where potential is VA, and it is reaching a point VB. Okay, you have solved some kind of this kind of questions. Okay, and they asked you what is the final kinetic energy. So final kinetic energy means potential difference is delta V. So delta V is final potential minus initial potential. So this is the potential energy, potential difference, and potential energy will be delta U is equal to Q times delta V, and this potential energy will be can be written as Ek Q delta V, or half mv square equals to Q delta V. Okay, so kinetic energy, velocity, etc. can be calculated from this formula. Okay, here also I have given you the formula. So basically you are calculating this term. Via this term, the potential energy stored is actually the kinetic energy, and this is equals to half mv square, right? Here v is the velocity. You should use this formula to calculate velocity, final velocity, when a charge is being accelerated in a potential, right? The work done in stored as potential energy and can give rise to electric potential. Sometimes what is happening, we do some work, external work in an electrostatic system, and that work is actually stored at potential energy, and that potential energy can give rise to potential. Okay, so in sometimes they will see, okay, 10 joule work is done on a 5 coulomb charge, then what is the potential of the system? So potential difference of between these 2 points. So potential difference is basically you have to divide the potential work done by charge. Okay, so from this formula you can calculate the potential by delta W divided by Q, right? So everything is related, everything is interrelated. If you understand these concepts, the interrelated relation between the quantities, then any problems you can solve. Okay. Now potential due to a point charge, very important formula. Okay, V is equal to 1 by 4 pi epsilon naught Q by R, very important formula. Potential energy is potential is given by this formula, and if, now let's look into another few formulas. Potential energy due to a point charge, E and V comparison. So we know that electric field due to a potential is given by, electric field is given by, if you remember, 1 by 4 pi epsilon naught Q by R square, right? And potential is given by 1 by 4 pi epsilon naught Q by R. Okay, so one is R square, another one is R. Okay, R square means what happened, it starts when the R value is very small. Okay, this value of E is very high compared to V, but when the R value is very large, E value is very small compared to V. So E starts at very high value, okay, but it goes to 0 very quickly, whereas V starting at slightly lesser value than E, but it goes to 0 slightly slower than that of E. Okay, at this point, if you see this, there is a point in each combination, there is a point where electric potential and electric field is equal. Okay, there always exists a point where they will cross. So crossing means at this point and this point in this given graph, this is the point where electric field and electric potential are equal. Okay, now this is very important comparison where we are discussing about electric field and electric potential. So electric field on the axis is given by 2p by r cube. Okay, electric potential is electric field at axis is given by this. So axis is this point anywhere here. Okay, on the equatorial plane is somewhere here. Okay, so this is given by 1 p by r cube. But electric potential is a scalar quantity and it is given by V is equal to P cos theta by R square. So P cos theta is the angle made by the direction vector R, angle made by this direction vector R, okay, along with this vector P. P points from negative to positive, right, as I discussed in the electrostatic chapter. So P points from negative to positive. We will do electrostatic potential and electrostatic charges and field division as well, but I am doing this chapter division first because for this week's KPL. Right now, if you see, EA is proportional to R cube, right, and EQ, that is equatorial plane, also proportional to 1 by R cube, whereas potential is proportional to R square. Now, if you see, on equatorial plane, at any point on equatorial plane, this angle theta will be 90 degrees. So this theta is 90 degrees. So in that case, cos 90 is 0. So on equatorial plane, potential is 0. Equatorial plane, potential is always 0. You should remember, any point on the equatorial plane, does not matter, it will be 0 at any point on the equatorial plane. Now equipotential surfaces, we already discussed about equipotential surface. If there is a point charge, so there is a spherical symmetry, all symmetrical points will be at equal potential, right? So all the points from this charge, those who are at same distances, they will have same potential, right? They will have same potential, and for any charge configuration, equipotential surface through point is normal to the electric field at that point. So equipotential surface, basically if you take any point on the equipotential surface, that surface will have a point where it is actually perpendicular to the electric field. So electric field is in this direction, and the surface is basically, if you take, this is tangent, right? So tangent means it is normal, okay? So any surface means it is a tangent, right? At that point electric field is normal. So normal means 90 degrees, okay? And work done to move a charge on an equipotential surface is 0. I asked this question while teaching. So when you are moving a charge from, say, a point A to point B on this equatorial plane, so no matter which path you take, work done will be 0, okay? It does not matter on the path taken, work done does not matter on the path taken, it only depends on the first starting point and ending point, okay? If the starting point and ending point are on the same equipotential surface, work done will always be 0. Remember this fact, it does not depend on the path. So they might ask you some question like, they have given an equipotential surface and they said, okay, the charge is being taken via path A, path B and path C, which case work done is maximum. So work done will be 0 in all cases, it does not matter, okay? Now relationship between electric field and potential. So electric field is given by delta V by delta L, or in differential terms dV by dl, okay? And in sometimes we have seen in our current electricity chapter that potential difference itself is given. So delta V, even though it denotes the potential of single point, in some cases instead of giving delta V, because delta V is coming so many times, instead of writing delta V, we write potential difference as V directly. So in that case V by L, okay? If you remember the drift velocity, drift current, where we have done this, sorry, not drift velocity, after Ohm's law, when we are deriving the formula J is equal to sigma E, right? In that formula we have used this relationship where V itself is the potential difference and L is the difference length of the conductor, right? So that is also very much possible, okay? Electric field is in the same direction in which the potential decreases the steepest. What is the meaning of that? Basically it means that electric field is basically negative of dV by dt. This is called potential gradient, okay? dV by dl, potential gradient, and electric field denotes in the direction where V is decreasing, okay? If V is increasing, electric field will be in the opposite direction of that, okay? So it is in the direction of electric field decreases the steepest, okay? Now let's move on. Potential energy, electric potential energy. Potential energy means electric potential energy, okay? Now electric potential energy between two charges, suppose we have two charge system Q1, Q2, okay? Then this is the potential energy of this particular system. Now if this entire system is kept in an external electric field, and if this is the potential energy of this point, and this is the potential energy at this point, then electric potential at this point, then for this system electric potential energy can be written as Q1 VA plus Q2 VB. We have already learned that, right? We have already discussed it, but you sometimes what happens when you are giving a regular lecture, you might be not paying enough attention. You may have overlooked some of the concepts. So I am explaining that again, okay, so that you don't get any confusion. This is only when two charges are present, okay? This is only when two charges are present. This is when the system is kept in an external electric field. So this is when external electric field is present. Here external electric field is 0. Here external electric field is 0, okay? Now potential energy of a dipole in an external electric field, this is very important. So we have done this already. We have done this while talking about this topic. And if you see the derivation, we are getting initial cos angle minus final cos angle, not the opposite way. In most of the derivation where we are doing the derivation, we are getting final minus initial, but in this case the cos angle is initial minus final. Okay, and P times E. Okay, P is the dipole moment. Actually, it should be small p. Okay, small p times E. Small p is the dipole moment and E is the electric field. Okay. Now, dielectric constant, let's move on. We have completed everything about electric potential and electric energy. Now, dielectric constant is the relative permittivity. Relative permittivity is the most important in the dielectric constant part. Apart from the concept of dielectric that we have already discussed in detail, in depth, the videos are already there. You can go and check electrostatic potential and capacitance chapter, video number 3, where we have discussed everything in detail, right? Now, dielectric constant or relative permittivity is given by epsilon by epsilon naught, that is epsilon of permittivity of the medium divided by permittivity of free space. Okay, and remember that the permittivity of in case of a metal is infinity. Permittivity for a metal is infinity. For any other metal, permittivity is not infinity, it is greater than 1. Permittivity for free space or vacuum or air is 1. Okay, permittivity for air is not 1, sorry. Dielectric constant is 1 for air, vacuum or free space, right? And K is infinity for metals. Okay, which is for free space or air. This is for metals. Okay, you should remember these interesting values. Sometimes they will ask you these questions. Okay, now parallel plate capacitor. Next, very important for your tomorrow's test. There will be a lot of question based on this concept. First of all, capacitance is given by Q by V. Okay, and it is given by Ka epsilon naught by D. Okay, so capacitance is given by, what is the meaning of this? K is obviously dielectric constant. K is dielectric constant. A is area. Okay, epsilon naught is free space permittivity. D is the distance. Okay, so if we have a parallel plate capacitor of surface area A, distance D, and some material of dielectric constant K, then this is the formula for calculating the capacitance. Okay, in case nothing is there, air is there or vacuum is there, then in that case I already told you K is 1. So, that will be A epsilon naught by D. But as soon as you are inserting the dielectric constant, what is happening? It is increasing by K times. So, initially suppose I have 1 microfarad capacitor and I inserted a 2 dielectric constant of 2. So, it will be 2 microfarad. So, it will be already twice. Okay, based on the value of K, what is the dielectric constant of that medium? Based on that, the dielectric capacitance of the capacitor increases. You should remember this very clearly, that capacitance increases as soon as you are inserting a dielectric medium. But if capacitance is increasing, that means potential will decrease across it. Charge remains same. Okay, if you are not connected to an external power supply. If it is you are connected to external power supply, your capacitance will increase, the potential decreases immediately, but then battery will try to regain that potential and you will gain more and more charges. Okay, but if you are disconnected from the battery at that point, then the potential will immediately decrease. Potential decreasing means potential energy will also decrease. Now, let us look into the formula for energy stored. Energy stored is given by U equals to half C V square. This is the easiest formula to remember. I told you some other formulas as well. CV is equal to Q. So, Q into V, or you can write this as half Q square by C. That is also okay. Okay. These are the 3 formulas that you should remember about energy stored. Next is series combination, when you connect multiple capacitors. This is the capacitor, right? And the symbol for capacitor is this. Series combination is one when one ends, another one starts. Okay. In that case, the equivalent capacitance is not C1 plus C2. If you are thinking C1 plus C2, no, it is wrong. That is for resistance. For capacitance, it is C equivalent equals to 1 by C1 plus 1 by C2 plus dot dot dot. Now, if only two capacitors are involved, only if, two capacitors are involved, in that case, special case, only two capacitors are involved, then we can write C equivalent as C1 C2 by C1 plus C2. This is only valid when two capacitors are involved. Don't try to use this formula for three capacitors. Okay, C1, C2, C3 divided by C1 plus C2 plus C3. No, that is wrong. Okay, you should not try that in your solution if more than two capacitors are involved. If more than two capacitors are involved, you have to use this formula. Parallel combination, in case of parallel combination, it is the easiest formula. Parallel combination C equivalent is C1 plus C2 plus C3 plus dot dot dot. Okay, there is no problem in that. Okay, so if you remember all these formulas, you will be able to solve more than one question in your KCET. Remember that. If you remember these equations, you will be able to solve more than two questions. Also, if you are preparing for JEE and for your board exam, these formulas are very, very important. Now, if you have not yet subscribed to our channel, please subscribe to our channel. There is a playlist available in our channel. You can check all the playlist, all the videos that is already uploaded in there. Okay, and whatever videos that we have completed in that part, everything is available at one place. KCET 2025 Physics 60 out of 60 series. There all the videos are getting updated and uploaded. Also, I am personally commenting on those videos, on those comments that you are posting. So if you have not yet subscribed to our channel, please do subscribe to that channel. Also, I request you subscribe to our WhatsApp channel as well. There you will get all the latest updates. As soon as I am uploading one video, that will be also posted there. And KPL that is coming tomorrow, test number 2. I hope more number of students will appear for this week's KPL, and they will mention, sir, I scored this much marks and I have not cheated. So without cheating, if you are attempting those questions, that is for your own benefit. Once you have completed the questions and you are curious and you cannot wait for my solution in the evening, you can do the Google. But first you attempt the questions honestly, and then mark. You take a notebook. Okay, you don't need to have anything else. You can download the question paper in your mobile or in your laptop. Read the question, try to answer, solve that question, and somewhere in that notebook you mention mark. Okay, question number 1, option A is correct. Question number 2, option B is correct. Like that you mark them. Once everything is done, and then you think, okay, this question might be very interesting, I was not able to solve, I have only done the guesswork, then you can do the Google and check. But do not correct that. In the evening when I am coming, I am discussing all the questions, all the answers, check all the solutions, and then you score yourself. Okay, out of 30, how much I have scored? I have scored right now, I am at say 10 level. Okay, out of 30, I scored 10. After 100 days, that is still some 90 days is left. After that is over, then again rate yourself. Okay, how much I am scoring now? So you will realize your improvement yourself. Okay, and also you have to go through all the lectures to improve your score. You cannot do it. Okay, one lecture I will skip, I already know this chapter, but you may not be able to answer the questions. So be careful, and also I request you follow all the lectures. And if you think this is changing your life somewhat, please give it a thumbs up, and thank you for watching this video. Happy Ganesh Chaturthi.